Welcome to this match-t DSM video tutorial. In this video we want to show you how you can influence additional parameters to create a DSM where you really highly emphasize to only get points on top of single objects or also in general on any objects that are not on the ground. This of course has some drawbacks. So if we have not so good imagery and we have more invalid measurements and some off shots, they can have an influence on our result. But in general, if you want to push your point cloud and your final result further towards your DSM, then this video is exactly that you want to look for. In this video we will focus on three main parts. We will discuss about the terrain type, which is strongly recommended to use extreme because it will automatically set many parameters already into our right direction what we want. So filtering, smoothing, and also these wrong measurements then will be more emphasized towards really a DSM. Secondly, we will take a look at the match status file, and we will here mainly influence our result by three settings. One is the num sector, and the second is the DTM shift, and the third one is with our CBM run to output every single pixel. And finally, also we will take a look at the filtering. So there's an option to have an influence on the gross error and curvature filters of match-t DSM, and we will activate them and show them how you can change them. In preparation to be able to use a match status file, I can strongly recommend to take a look at the reference manual of match-t where it's described. We will here just make a shortcut. So what we need in this case here is a text file, and I will here just use this file. It has exactly this naming, match.status, and you place it in the folder where your info project is located. And in the status file, when we take a look at the content, there's only at the beginning a single entry, and this single entry is -create option file. And this is a trigger. That means we will now open an info project, or this info project here, because it has to be the one where the status file is located. We will start any project. It will not calculate a point cloud. It will detect this match status file and fill the status file with the newest content of possible parameters that can influence match-t in its process. In our example, we will run here a very small dataset just to showcase here how the parameters have an influence, and we will also use here a borderline so that we have in this flight, which is here a 60-60 flight, then central part where many images are looking into the same location. And this is also something that has already an influence. We will see this with the num sector, but in our case here we have now multiple images looking at the same position in our real world. If you have a 60-30 flight, then of course you have less options, but still there are still options or some areas where you have then at least 4 images, sometimes looking at the same part, or 6 images. So therefore also here the num sector can make sense, but in general here with the 60-60 we have a little bit more flexibility for the num sector parameter, which will be explained later on. Just that you know, when we import later on our borderline, this is the area that this polygon is covering. So let's take a look at the project and go to match-t. So we are going to match-t, and in match-t then we will now run here this project, but because we have now in our project folder this status file, we will now not process, so I can hit the start button and it will detect this status file. So here we can see it's already finished, so it will now here fill out this file, so we can here directly close it again, and we can now access it now through this button. So if I click here match status file, then this opens exactly this one file that we have just taken a look at in our folder. This file is continuously changing, and we take out parameters, we add new parameters, we change some behaviors of some parameters, really just because here we try to be flexible, but also therefore there is no documentation for it. I will also now simplify here this status file, only leaving these parameters inside here that we will talk about, so we don't get confused with all the other stuff. So here we go. We left the parameters that we are interested for today in. So we will have an influence by the num sectors. And what we will do now here is we will emphasize that for each matching, we will always try to find for one sector models from different directions. Yeah, so there's in the reference manual a graphic or not. I just checked, so let's perhaps explain it then here this way. So when we have here our images and we take here a location here and we want to match this sector here, then there are these different images able to look at this position. And we can now always take a pair of two images and they generate a baseline. So if I take here, for example, image 514 with 515, then this is my base, and therefore this is a direction where I'm looking at this sector here. I can also take 514 with 1503. So 1514 with 1503, and then this is my base direction, and then I can also look at this part. And I can take image 1514 together with 1500, and then I have here this baseline, and then again I have a different epipolar line. Yeah? So the epipolar line is always in relation to the base of an image pair, and therefore I can look here from different sectors into the same location, and therefore I have different viewing options. I have different epipolar constraints, and therefore I can get different amounts of raw data points for this location to generate points for our point cloud. By setting the num sector to 6, I always want to use these different models. This is by default, this is an adaptive parameter. Depending how good the quality of the points in one sector are, we can then here vary this part. But if we set this to 6, we will always take more models into account, so it will take longer to process, but also we have more options to see perhaps on top of a tree, on top of an object, and therefore that's why we want to here enhance the point cloud density and also the raw data that we get. Then it doesn't help me to get a lot of points. We also want that all these points that we get in one sector, we want to emphasize to take the highest ones. And this is exactly where the DTM shift comes. So we, in this case here, we will here take the first dash off, and we want to here use the plus instead of the minus. So we take the minus and the slash off. So we make a plus DTM shift. And therefore, in one sector or in one cell, raster cell, we will then emphasize the points that are on top and therefore try to stay on top of our objects that we have. By using the terrain type later on, extreme, we automatically make our cells smaller, and therefore we can be here more flexible in specific small objects that are close to each other, and therefore then still keep here the DSM as good as possible. Next one is point density, and as we already tried to match from different models, so this is then our data collection, we also want to output from the raw data as much as possible. So what we will do is here we will generate our point density with every pixel with the CBM process, which is a lot of more data, but a lot of more data can now be also used to filter. It can also be evaluated. We hopefully get then a few more points on top of a tree, so we can then with the plus DTM shift stay on top of the tree, and therefore this will then just here as a quantity part increase it. But it's not only quantity, because each of these matchings is still taking care about this num sector, and therefore we hope then this will then help us to get a more quality point cloud and denser quality point cloud. So this is all match status related in combination with the terrain type. Terrain type, perhaps we remember from the PowerPoint, in this case here, has an influence in general about cell size, filtering, and also about gross error detection, and automatically. And now additionally we can manually also add here the filtering options in our user interface. So we activate this one now, and I will showcase immediately where this will show up. So let's here save this here, and then we can here exit, and here exit. And when we now go into our edit part and we go here into our strategy, then we will then hopefully, let's see, I think I will need to reload. So here we see at the moment not these entries here. I will here just leave it as it is. Let me say here OK, and here also OK. And here close this part here. And do you want to save? I want to save, yes. Let's restart match T. Let's go back into the edit part. Let's go here into our strategy. And now we see these filterings. So this is because we have changed here in the match status file this minus filtering, and that gives us access now here in our parameters here about these filter parameters. Okay, and here we go. So now we have everything that we need to set up the advanced parameters. And let's here generate from the gecko. So I will now again import, or let me remove here this previous one. We will import our polygon, and with this polygon we will then here start to process this area, this small area that we have seen at the beginning. I will here edit this part. I will call this now here advanced DSM. We will change our strategy. There is already one that I generated, but let's here make a new one here. We will call here new, and I call it here extreme DSM. Then I will change here the terrain type to extreme, and this has now the changes as we have seen in our PowerPoint. Let me just here grab it in here. So this will have an influence on our filtering. I will show this immediately. And smoothing, so both of them are now these filter parameters, but also on the data snooping. And not mentioned here, perhaps I can add this here also, is the cell size. So this has then all an influence on these parts. And this is full automatically done just by setting here extreme. And by changing to extreme, we can, or perhaps go to flat. You see here, if I say flat, we already have here changes. And we can then also here go to extreme, and then we see here feature density goes to dense, parallax threshold is going to 20 pixels, and our point cloud density here is 3 pixels. Okay, I can here directly access it, so I should not have needed even in the match status file to place this to 1. So you can also influence it from here. Then next part is already done from us because we generated the match status file. So we will now run this project with the num sector 6 with the plus DTM shift, and I can remove this here, so every pixel in this case here does not need anymore to be set. We can do this through the user interface. And finally, we also now have the filtering options for gross errors and for the terrain curvatures. And this is then here done by these parts here. So the gross error is in this case done, or an influence from the gross error is done by the smoothing rate of the 3D points. So this is really the raw amount of data that can be eliminated. So in this means if I have 100 points, 30 points are eliminated and we remain with the other 70 points. So this is really a full statistical point. That means if I say, okay, my image sensor data is good and I will not have 30% of trash, then we can reduce here this amount down to 25% or to 20%. And that means we will only remove 20% of our raw data and work with our remaining 80%. The curvature part here is now how much smoothing we want to allow into our final result. And the smoothing is then calculated in X and Y directions by curvatures. So in this case, this is a finite filtering algorithm. And the lower we, when we move this filter here to the left side here, then we allow more peaks in our raw data. Well, you think, oh, then I put it also down to 20. Well, this is not this easy because there's still a mathematical raw data that is generated. So in general, it would make sense something to stay around of 50 perhaps, instead of the default 60. And then you have to see really how strong, in this case here, your data will then have offshots in this part. But in general, something around from the 60s going down to the 50s would then allow us to have more peaks in our final result, and therefore this can then be also changed. These values are also triggered by the model type, CBM and DTM, so they will have then a different influence how they will be applied. In general, and this is why here we always see here the term, we want to detect with this gross errors and minor errors. So that means by eliminating points in before, we will try here through iterations to eliminate gross errors. So this is the main goal here. That means we want to have really a point on top of the tree and not some other points on top there because a bird was flying over or the image is a little bit more blurred and there was a mismatch. So this is really taking care that we don't work with false data, and therefore false data, if we filter more out, then of course we have no false data, but therefore we smooth it more and more, and also additionally we will lose these peaks and these small details on top. So therefore we are now on purpose here trying to reduce these values so that we can get more of the top of our objects and trees and whatever we call a DSM. Okay, so there we are. So we can now here save this strategy And this strategy now will be applied. So we say yes, we want to apply it. And this will then be applied to this process now here. And in our case now here, this is, let me just check here. Yeah, I don't want to generate additionally a grid. So that's it. And then we output now this here to output DSM extreme. And we say select. And this is so far. And that's it. We are fine. So we can say here, okay. And then we can now here save the project and run. And because the match status file is in this project folder, now these parameters that we have changed, so these ones here, they will now be considered. I can take this point density out here, take it out. So let's minimize everything that we need to do. So only these 3 parameters have been now adapted. And then we can here save it. And then let's run. We hope this helped you to make MatchT DSM better run for DSMs. So thank you for watching and have fun and have a nice day. Goodbye.